So let's take a look at TypeScript, and if you've never used TypeScript before, then don't worry too much about it. It's really just a superset of JavaScript, and all of your JavaScript knowledge is equally valid inside TypeScript. And TypeScript is really just going to allow us to strongly type our JavaScript variables, which are not strongly typed in JavaScript. And all of our code that we write in TypeScript is going to be compiled into JavaScript. And if we take a look at this tsconfig.json file, one of the files that we got from React when we installed our application with Create React App, or created our application I should say, then what we have in here is our compiler options. And when we used Create React App, we also added TypeScript so that we can use this in our application. And this comes with a TypeScript compiler. And the compiler options are configured inside here. And any code that we write is going to be targeted to the ES5 JavaScript version. But we can choose any type we like, but bear in mind that not all browsers are going to support the most up-to-date version of JavaScript, so ES5 is a perfectly fine JavaScript version to target, which has maximum compatibility with browsers. So what I'm going to do is just create a little demo file, and I'm just going to call it demo.ts. And anything I create in this little lesson is going to be removed afterwards. And inside this demo file, I'm just going to declare a variable called data and set it equal to 42. Now, our TypeScript compiler is already complaining because it says that all files must be modules when the isolated modules flag is provided. So I'm just going to discard the isolated modules. And in fact, I'll just set this to false, just so I can not see warnings whilst experimenting. And with this let data equals 42, if we hover the mouse over the data variable, then TypeScript has inferred that this is a type of number. And if I was to try and assign a string to data, then we're going to get a warning or an error saying that type 42 in quotes is not assignable to type number because it's a string. But if we don't declare an initial value for data, and I just remove the initial value, then the error goes away, and now data has been given a type of any, because I didn't specify the type when I declared the variable, and I didn't give it an initial value. So we can be explicit about the type as well, and I can specify a colon and then a type of number. And now we get the error again. And we can also be explicit about declaring any as well, and the error once again goes away. And what we can also do is, if I did want this data variable to either contain a number or a string, then what I can do is give it a union type and specify that this can be either a number or a string. And again, the error goes away, and now the data type has a type of string or a number. But when it comes to simple values like a number, for instance, specifying the type is redundant. And if I just add the number back in, and let's just change this so it doesn't give an error, then specifying the type here is pretty redundant. It doesn't have to be there. So this is fine for simple variables, but what about objects? And typically in our application, we're going to be using objects, certainly for the stuff that we're receiving back from our API. And just for example's sake, I'm just going to create a couple of objects for cars. I'm going to have car1, that's going to have a color equal to blue. And the model I'll set to BMW. And let's have a car2 that's got a color of red. And the model is, let's say, Mercedes. And in this case, let's give it a top speed equal to, let's just say, 100. And these are just normal JavaScript objects, and it's inferred the types of the properties of this object from the usage. But what we would also do for objects such as this is we'd create an interface which will define the structure of the objects that we're creating here. And typically interfaces start with a capital I, and inside our interface we'd define the properties that we'd expect to see. And in this case we'll have a color which is of type string, we'll have a model, again of type string, and then we can assign the type of the car to the objects. And I'll say const car1 is a type of iCar, and then we've got car2 again, which is going to be a type of iCar. And now we see the error for the top speed because that's not declared inside our interface here. And if we hover over the warning, we can see that top speed does not exist in type iCar. So what we'd need to do is add the top speed property inside here as well and specify this as a type of number. But then of course we get an issue with car1 because top speed is required in type iCar and it hasn't been declared here. So what we can do to get around this is to make the top speed optional so that if we do create a car object of type iCar, then we don't have to specify the top speed. So we can just make this optional by specifying the question mark here. So what we can also do in TypeScript is deal with functions as well. And let's supposing I had a function called multiply. And we pass in two arguments, x and y, and we return x multiplied by y. Now our compiler is complaining because our arguments implicitly have an any type. And when we use the strict type checking option, then we're not allowed to implicitly specify variables as an any type. What we can do to get around this warning is explicitly give them an any type. And if we hover over the multiply function, we can see that it takes x as type of any, y of type of any, but we return a number. And it was able to infer that we're returning a number here simply by use of the multiplication operator here, because if we're multiplying something by something, then it has to be a number at the end of it. So what we can also do is be explicit about the variables in here as well, and we'll specify number for x and number for y, and everything stays the same. We take in two numbers as arguments and we return a number. But what we can also do is be explicit about the return type here and give this a type as well. And supposing for whatever reason I didn't want to return a number from this particular function, then I could specify a return type of string. And once again we see the warning because number is not assignable to type of string. So what we would need to do to return a string in this case is set this to a string, and then the error goes away. And of course functions don't always have to return anything. TypeScript was inferring that we've got a return type here in the first place because we've got the return specified inside our function. But if we're not returning anything, supposing this was just a function that carried out some sort of side effect and we just had x times y in here, or x multiplied by y, then now we've got a problem because our return type is a type of string, but because we've got this string as a return type, we have to return a value from this function, and if we don't, we get an error. So what we can do is we can also be explicit about this and say that we're returning void from this function. But again, the void is redundant because TypeScript is going to be able to infer from the fact that we're not returning anything, then it's going to be returning void, so we can also remove that type definition from there as well. And if we hover the mouse over the multiply, then we can see that this is returning void. So this was a very quick introduction to TypeScript. We'll be doing lots of practice with TypeScript throughout this course, and this was just to give you an idea of what it means to specify types onto variables and objects in TypeScript. And what we'll take a look at next is how we can use TypeScript in the context of our React application.